Cambridge AS Computer Science, Chapter 8, Databases. This chapter talks about creating a database. We have programs to deal with databases. For example, Microsoft Access creates a database. What is meant by a database? A database has table, and that table has fields, and one of them will be a primary key, one of the fields in every table. And also, you may have several tables that are linked together with relationships. This is called relational database. This is in contrast to using file-based database. So sometimes in programming, you write code to read or write a text file on a computer. This is not a database. This is file handling, and it can only handle very simple situations, because in this scenario we have text file, and that text file may contain several fields. They are connected together, they are not separated in the form of fields. It's not a record. Okay, so we will use the database approach and compare it to the file-based approach, where you read and file data manually using a program from a text file, for example, and see how useful it will be to use database management software, DBMS, Database Management System, that is technically program like Microsoft Access. Okay, so we have to study data. What is file-based approach? A file-based approach where you read and write data in a text file using programming. You can only deal this with very simple amounts of data. Very simple amount of data. You can read it and write it in a text file, and probably they ask you why. Probably you will copy the array, the data of an array, and store it in a file, and then they ask you, why do you need to do this? You say, if I turn off the computer, data in the RAM will be lost, and data in a file will not be lost. Okay, so if you create the database, it's not called a database then. If you save your files and you read the data using programming, okay? So file-based approach is when data is stored in a file and a program is designed to deal with this data. You have been doing this in pseudocode. You will be doing this in Python, reading and writing to or from a text. However, I would like to teach you today the database approach. In the database approach, you use a database management system, DBMS, like Microsoft Access. Microsoft Access allows you to create tables. Every table consists of records. Every record consists of fields. And one of these fields will be unique, will never be repeated for any record. We call it a primary key, like, for example, the ID number. And using database management software, you may create another table and then link the two tables together. And then using database management software, you can create queries. What are these queries? To apply search conditions to reach particular information across 2 or 3 or more tables. Okay, you may create reports, you may create data security, you may protect one table with a password and the other table with another password. Database approach gives so many benefits in dealing with data. Okay, so the database approach is when a database management system, DBMS, is used to manage the organization and storage of data. Okay, so this is a database. You can have data storage, data retrieval, administration, software application. The good thing is that with that approach, you have a separation between the programming and the data itself. If you change the structure of the database, you don't need to create another program because the database management software can create or deal with any possible data structure. Tasks that can be performed using a database management system developer interface. You may have buttons. That buttons will help you create tables, queries, forms, reports. Okay, so first you create a table. If you have taken ICT, you would have been using Access. Okay, so create a table, set up relationships between tables, create a form for easy entry and retrieval of data, create a query to apply a search condition for data in one or more tables, create a report to display the results of the query in a nice looking way. Okay, so this is the file-based approach and this is the database approach. What are the limitations of a file-based approach? We will talk about this many times. Many times we'll talk about benefits of the database approach that fulfill the limitations or covers the limitations of a file-based approach. Okay, so what are the limitations of file-based approach is that you just store data in a file and create a program to read and write data in that file manually. It is like you have to create everything. Even in the text in file-based approach, you have a line of text, you have to separate it into fields, and that would be very complex. Okay, limitations of a file-based approach. Limitations of not using a database management system, of not using a software like Access. Limitations of saving your data in a file and writing a program in using Python, for example. Okay, what are the problems you will face? Because these will be overcome, inshallah, by the use of database management software. Number one, data integrity and data privacy concern. If you save data in a file using a program, in a file-based approach, a file-based can lead to data integrity problems. So data is incorrect. Data integrity means data is incorrect. Okay, the reason is that lack of built-in control when data is entered. For example, validation. The database approach can prevent such a problem, minimize this may happen. Okay, by using validation and verification to make sure that data is correct. So data integrity is that data is incomplete, incorrect, inconsistent. A file might have thousands or more of lines. I would love if these are records. If there are no validation techniques that would detect errors. A different problem is that of lack of data privacy. When you have database management software, you can create passwords to protect individual parts of the database. When you have a file, you cannot protect it with a password. So security is better using database management software. Okay, data redundancy and possible inconsistency in multiple files. We will learn how to create a relational database. In a relational database, you have data, you avoid data duplication. You never write the same piece of information more than once. You put it in a table and link to that table. This reduces data redundancy. Data redundancy when you need to type the same piece of information twice. And this also reduces data inconsistency because if you type data twice in the file-based approach, because you don't have relationships, and for example, you update one version of data and you don't update the other, then you may suffer from data inconsistency. Okay, there may also be data duplication across the files. This is commonly referred to as data redundancy. This can lead to data inconsistency. All these bad things are in the file-based approach. Okay, lack of integrity. Okay, the last thing about problems with file-based approach is that program data dependency. What is program data dependency? When you write a program to store some data, okay, and you need to modify that data, you need the structure of that data, you need to modify the structure of the data, you need to modify the program. However, if you are using DBMS, that is database management software, for example, Microsoft Access, but commercial names are not allowed in your syllabus, okay? The program is ready to deal with any data. If you modify the data, you don't need to modify the program. Okay, so you eliminate data program dependency by the use of database management system. Programmer write a program and at the same time define the data files that the program will need. The programmer has to know how the data is organized in these files. This is an example of program data dependency. If there is a need to change the data, this will require the existing files to be rewritten and the program to be rewritten. Okay, if you are using the database approach, this is the database approach. And we are going directly to relational database. What is a relational database? Now we will use the database approach. Okay, where you create a database using a database management system. Okay, this is very flexible because you create tables. You may create many tables and then create relationships between these tables. You did that if you have studied ICT. And in ICT, all the relationships must be one-to-many. Here also in AS computer science, relationships must be one-to-many, with some understanding why they should be one-to-many. What is one-to-many relationship? It is the relationship between a primary key in one table with another non-primary key in another table. What is a primary key? A primary key that could not have data duplicates. For example, your candidate number, you cannot have two candidates with the same candidate number because we want the candidate number to be unique. We use it in searching and also in building relationships. And that primary key will be the one side in the relationship. Okay, so a relational database is a collection of relational tables. What is meant by relational table? They are tables. This is a table, and these are the fields in that table. Okay, and these are relationships. PK means primary key. Okay, so every table will have its own primary key and will be used to link with other tables, probably with a non-primary key in another table. And then this will be called foreign key. Okay, so this is a relational database. Let us go into details and see how codes are written to describe that database. When a table is created in a relational database, it is first given a name. So for example, I would like you to understand that type of coding. Okay, because soon we will be studying SQL, structured query language. Okay, so when a table is created in a relational database, it is first given a name. For example, the table here is called member. And then attributes. What are these attributes? Attributes are fields in that table, like this. So this This is the logical view of the table, and this is the code of the table. So the table is called member. Okay, it is called member. And it has a field called member ID. This is a field. And it has a field called member given name. This is member given name. Another field called member family. This is member family name. And then band name. This is band name, etc., etc. Maybe there are space for more fields here. Okay. So this is one of the table. The other table is called the band. And oh, before I go, the underlined field is the primary key, because member ID is the primary key. We will not make it possible that two members will have the same member ID. Maybe two members would have the same first name. Maybe two members would have the same second last family name. But we will never let it happen that two members have the same primary key. Will not have the same member ID. And this is the primary key. Okay? So the primary key is always underlined. Okay? And this is the other table called band. Okay? And we have band name and agent ID. And please try to notice that band name here and band name here may be used to link the two tables. So for example here, band name computer kids, and this is band name computer kids. So I can know that this member of that band, IT Wiz, this is IT Wiz. So I can know now. Then this is what is called a relationship. This is what is called a relationship. Okay? And this is the primary key. The band name is the primary key. And here it is not a primary key. It is the foreign key. And that kind of relationship is one to many, which means many members can belong to one band. Okay? Please look at this, because this is the basis of a relational database. So this is the typical scenario of having a relational database with two or more tables linked to each other using relationships. If you cannot have relationships, you would need to write all the details of the band again in front of every member. And we call this data redundancy. With relational database, you avoid data redundancy. Okay? So this is the logical view of the member table, and this is the logical view of the band table. If you look here, you find agent ID. Okay? So probably there are other tables that link to the band name. So we would like to link as many tables as we could, because if you split everything to its primitive organization, so this, for example, it may be, for example, that the band name computer kids deal with agent ID 01, for example, and there would be another table that contains the details of that agent 01 linked to that field. And IT Wiz links to another agent with another ID number. Okay, so we have several tables interlinked together, and maybe here I don't have the other table that links to the agent ID. That's why it is not very clear. I only want you to understand the principles of having several tables, and those tables are linked together using primary keys. Okay, so don't mind much what is written here about agent ID. Just look at definitions. A record is a special type of a relation. A relation is a special type of a table which is used in a relational database. Here we will face many words with the same meaning, and this may cause some confusion. Okay, so a relation is a table. A relation is a table. However, it is a table that is involved, that is linked to other tables. So it's a special kind of table that may have links to other tables. Okay, so a relation is a table, a special type of table used in a relational database. What is the relational database? That relational database that contains several tables interlinked using relationships. What is an attribute? An attribute is a field inside a table. It's a column. An attribute is a column in a relation, and a relation is a table. We see so many confusing words, okay, that contain values. This is an attribute. The attribute is member ID. Values are 0005, 0009, and so on. Okay, let us look at this. Let us look at this. Every row is called a tuple. Even more complicating words, more confusing words. A tuple is a record. Every row is a record. They just call it a tuple. But it is a record. So they are both the same. A record and a tuple have the same meaning. Okay? Every column is a field. They just call it attribute. And the whole table is called a relation because it is involved in a relational database. And this is a data value. And the customer ID is the primary key because it may not have duplicates. Unique. Okay? You may be familiar with some of these definitions if you have studied ICT. So the primary key is very important. Every table must have a primary key. And each tuple, that is each record in the table, must have a value for the primary key, and that value must be unique, which means the primary key cannot be left blank and cannot have duplicates. Okay? Although it is possible for database to contain standalone tables, it is usually true that each table will have some relationship with other table. This relationship is implementing using a foreign key. So probably a relationship will link one primary key to one foreign key. And that foreign key will be non-primary key, and there is going to be one-to-many relationship. A primary key is an attribute or combination of attributes, maybe two fields together, joined together to provide the primary key. Okay? Where a value in each tuple may be unique, should be unique. Okay? Next, what is a candidate key? A candidate key is a field that qualifies to be a primary key, but is not taken as a primary key, and some other field is taken instead. This is a candidate key in case they ask you what is meant by a candidate key. Okay? What is a foreign key? A foreign key is an attribute in one table that refers to the primary key in another table, and it is the most popular kind of relationship is the one-to-many relationship. We have degrees of relationships. We have one-to-one relationship. That is, one primary key in one table is linked to one primary key in another table. This is not very successful because I think you would combine both into one table and no need to split them into two tables. So one-to-one relationship is not a good kind of relationship. Just combine them together and make them one table. Okay, one-to-many relationship, this is the most popular. For example, customer to order. A customer may have many orders. Okay, soon we will talking about database normalization. Normalization to be in the best organization. In that time, I will tell you that all relationships must be one-to-many relationships. If the relationship is between many to many, if the relationship is many to many, that is between non-primary key with another non-primary key, it will not be a good relationship. You will not be able to manage it. You would rather split it with a table in the middle, calling that table in the middle a link table, and from every side will be one-to-many relationship and a many-to-one relationship. We will look at this when we do database normalization. Okay? So, what is an entity? An entity is something, a customer that will have table and eventually will have table about customers. A product and then eventually will have table about products. Vacations and we'll have a table about vacations. So entity is something that we will have a table or a relation about it. So an entity is something. So if a company has many vacations and have many customers, so vacations is an entity and customers is an entity. And also you will have reservations. That customer reserved that vacation. So reservations also will be an entity. And eventually every one of these will become a table. And they will be interlinked to each other using relationships. Hopefully, all these relationships should be one-to-many relationships. Okay? So entity, the concept of or object in a system that we want to model and store information of. It is something we want to store information about. It will eventually become a table. An entity is any object, person, or thing about which it is possible to store data. An entity will eventually become a table. Okay? So this is an entity. Let us look at definition. All the data about one entity, this is a table. So all data about one entity, it is a table. And sometimes we call the table a relationship. Okay? All the data in one row, this is a record. However, we may call that record a tuple. A column or field in a table, it's a column. We call it an attribute. Okay? So please study these definitions. They are rather confusing. They come in exams. They earn you plenty of them. Let us look at this. A relational database for a hotel using a database management system, DBMS. One line is drawn from each database term to its most appropriate description. So actually it came in the exam without the lines and your answer was to draw lines. Let us just study it. A field in one table that links to a primary key in another table, this will be called a foreign key. So you link the primary key in one table to a non-primary key in another table, and that non-primary key in that other table will be called the foreign key. Collection of records and table, nothing to match. Type of database that is being stored, nothing to match. A unique identifier for each tuple. Tuple means record. And this is a primary key, unique identifier. A data item represented as a field within a table. This is an attribute. Attribute is a field. Okay, the last thing, the concept or object in the system that we want to model and store information about. This is an entity. I hope you are familiar, you are becoming familiar with those terms because you will have to deal with them. Other examples. Okay, let us look at as many examples as we could. an object, person, or thing about which it is possible to store data. This is an entity. The database organized in rows and columns. The column form the structure and row form the content. This is a table. Okay? So, an attribute or combination of attributes that can uniquely qualify as a unique key, this is a candidate key. We know the definition. Attribute or attributes in a database that link to a primary key in another field to form a relationship, this is the foreign key. Attribute or combination of attributes that is used to uniquely identify a record, this is the primary key. I hope I'm repeating things until it is becoming very clear. Okay? Next, advantages of relational database over file-based approach. This is exactly the opposite of what we have been saying. We said the limitations of file-based approach. What is file-based approach? Is that you create a program that stores data in a file. And you leave all that big. It is a kind of science. You leave all that big science of database. Okay? It is better that you use a database and you use a relational database. In a relational database, you have tables that are linked using relationships. Okay? So what are the advantages? Storing data in separate linked table, so data redundancy is reduced. What is data redundancy? Data duplicates. There is nothing duplicate because everything is in its own table with links between the table. You don't have to write the same information twice. You just link to a table using its primary key and connect to its information without any duplicates. It reduces the data duplication. And data duplication is controlled. Compatibility and data integrity issues. If you have data stored more than once, you may suffer from data integrity issues. Okay? Are reduced as data only need to be updated once and is only stored once. Unwanted or accidental deletion is prevented. Database will flag an error. If you delete one record, we call this referential integrity. The database will warn you that if you delete this, some other data will be linked to nothing. So either stop deleting or delete the other dependent records as well. We call this referential integrity. Okay? Program data dependency is overcome because you have database management program that can deal with any data structure and you use it to define the structure. You don't need to reprogram your code. Okay? So program data dependency is overcome. Changes to the structure of data have little effect on existing programs. Fields can be added or removed without any effect on existing programs. Because actually, by that time, you will be using what is called SQL, structured query language, okay, to search the database, okay? Unproductive maintenance is eliminated. It saves a lot of overloads, okay? Complex queries. You can create a query from several tables. Security and privacy. You can set up a username and password for every table. Okay? Better control on data integrity. It will use data dictionary. What is data dictionary? Data about data. Okay? Validation checks. Okay? Okay, again. Features of a relational database that address the limitation of file-based approach. These are things are repeated 2 or 3 times. However, please read them carefully because they just make everything very clear. Multiple tables are linked together. Eliminate data redundancy. Data only need to be updated once. Unproductive maintenance is eliminated. Data program is in independency. So data and program, they are independent. The structure of data can be changed and does not affect the program. The program can be changed and does not affect the data. Data can be accessed by any appropriate program. Allow concurrent access to data. What if two customers are using the same record at the same time? One of them will have access to it, the other will be locked because we don't want their updates to overwrite each other. Complex queries, you can create queries from several tables. Different users can be given different access rights. Every user will have a username and password, and he will be able to see some data and not see other data. Different user can be given different views of data. They do not see confidential information. Data privacy is maintained. Okay, let us go to another part and then go to solving questions. What is entity relationship modeling? You will have to draw diagrams like this. This is an entity called the customer. This will be a table about all customers in the database. This is an entity called holiday. This is a table about all holidays available in that company. And this is another entity called booking, and every one of them will be a table. Okay, this is an entity called booking. And those three lines show that a customer on one side may make many bookings on the other side. And this reveals that this relationship is one-to-many. Yeah, he is very welcome. A customer may make as many bookings as he wish. Okay. Also, a holiday may have many bookings. So a holiday is a trip with like 50 seats. So you have 50 bookings. So this is entity relationship diagram. What is an entity? Something to store data about. A table. Okay. And this entity diagram shows the link between the table. Many times you will be asked to complete or draw relationships between tables. Hopefully all of them will be one-to-many. So see, this is one side and this is the many side. This is the one side and this is the many side. If you link customer to holidays, holidays to customer, it's going to be many-to-many. And it is impossible to manage. What's in the middle here, that booking table, is called the link table. Okay? So the top-down stepwise refinement to database design use entity relationship diagram. An entity could be a thing, a type of person. We told that. An entity is an object in a system we want to model and store information about. An entity is something that will become a table in a relationship. We said that. Okay, and this example is taken from the past paper. An owner has a holiday company database that include data about holidays. This is an entity, such as location, date, return days. Data about customers. This is another entity. And holidays they have booked. This is the third entity. The owner has normalized the database. We will talk about database normalization later. It is organized in the best way, where everything is linked using foreign keys and primary keys, and all relationships are one-to-many and no duplicates. Okay, the owner has normalized the database, which has three tables. An entity relationship ER diagram for the normalized database is shown. Okay, and for example, the customer table will have the customer ID as the primary key. The holiday table will have the holiday ID as the primary key. The booking table will have the booking ID as the primary key. However, that booking table is the link table. It has a foreign key customer ID that links to customer ID. So here it has a foreign key customer ID that links to customer ID in the customer table. Also, it has a foreign key holiday ID that links to the holiday data in the holiday table. Okay? That database is in the third normal form. We have to look at this. In the future, we will look at first normal form, second normal form, third normal form later on. Okay? Referential integrity. Ensure that related data in tables are consistent. Cascading deleted. If your example, you delete a customer, you must delete all bookings related to that customer. This is called referential integrity. If you update the data of a customer, you update all records linked to that customer. Okay? We can go here to normalization because normalization is a very big topic. Or maybe we can look at questions. Let us have a look at questions first before things get more complicated. Let us go to the classified page 345. This is the beginning of chapter 8, databases. Let us go and study some examples. Bobby and Kim are discussing database. Bobby tells Kim that a file-based approach is usually better than a relational approach. This is totally the opposite of what I've been telling you. The question says, explain why Bobby is incorrect. It is like the question is asking you to give all the benefits of database approach over a file-based approach. But they are making it in a scenario like this. This is the mark scheme. And probably some of this text is already copied to my notes. Flat file has more data redundancy. In a flat file-based approach, you cannot have relationships. So maybe you need to write data twice. So data redundancy, because the same data is stored many times. You cannot store data in different tables and link them because you don't have a database. There is program data dependency. This is very obvious with flat files because any changes to the structure of data mean the programs that access that data have to be rewritten. If you are using a database management software, it can deal with any structure of data. You don't have to rewrite programs. Flat file has more data inconsistency because you write data twice and you update it once in one place and you do not remember to update it in the other place. So you have worse data integrity because duplicated data might be stored differently. When data is updated in one place, it is not updated everywhere. It is not easy to perform complex searches or query. This is only possible in the database management software because a new program has to be written each time. Flat file would have lack of privacy. Users' views cannot be implemented. Okay, so just write 3 of these. Just prove that a database approach is better than a file-based approach. Okay. Bobby has a shop that sells products to customers. His database will store data about his customer, their payment details, orders, and the products he sells. Customer will have login details to access their accounts. The database will update customers' payment and login details without keeping any historical records. Give one example of each of the following relationships. From this, Give me an example of one-to-one relationship. From this, give me an example of one-to-many relationship. From this, give me an example of many-to-many relationship. So, one-to-one relationship is customer to paying detail. Every customer has his own payment detail. Okay? Or customer to logging detail. One-to-many, customer to order. Many-to-many, order to product, customer to product. Because customer produce many orders and every order can contain many products. And this is not a way of dealing with normalized data. So you don't like to deal with customers to products directly. This is a many-to-many relationship you cannot manage. You put a link table in the middle. That link table in the middle will be the orders. Okay? So from one side, customer can make many orders. From the other side, orders contain many products. Okay? And then instead of having many-to-many relationships, you have a link table in the middle and you have two relationships. Every one of them is a one-to-many. And this is called database normalization. We will study this later. Normalization means restructure your database in the best way. Okay? It is best that all relationships be. Tick one box to identify the relationship that cannot be directly implemented in a normalized database. If you have a many-to-many database, if you have a many-to-many relationship, this is not allowed in a normalized database. What is that normalized thing? It is not structured in the best way. Also, you may not have one-to-one, but this is very obvious. Many-to-many is really a distraction. Okay? Okay. So I'm trying to introduce you to what will be called database normalization. Let us study new topics on the question itself. It is so simple. There is a kind of codes that are used to create a database, add records to that database, and apply search conditions to that database. Collectively, these kind of statements are called SQL, structured query language. So, Bobby wants to name his database shop orders. Okay, write a data definition language, DDL. With SQL, we have two kinds of languages. First of them is called data definition language that allows you to define the database, define the tables in that database, and define the relationships between fields or tables in that database. This is called data definition language. And it is very simple. I will show you. Then there will be another kind of language called data manipulation language. This will allow you to add records to the database and to apply search conditions. Okay, so this is new. This is not taught in the lecture. However, we can just learn it on the question. It is so simple. Let us write a data definition command. What is data definition command? DDL. What is data definition language? A language used to define the database itself. To define a new database with the name. It is so simple. Just write create, then a space, then database, because you create, and all is capital. You create space, database space, and goes then goes the name of the database. This is a very simple command. Create database. It's very obvious. And then the name of the database. This is an example of data definition language. Okay? A database has a data dictionary. What is that data dictionary? Data about the data itself. 3 items in the data dictionary. In the data dictionary, we have the table names. We have the field names. We call these attributes. We have data types, integer or string. We call it text. Okay, we have type of validation, length check, range check. We also mention which one of them is the primary key, which one of them is the foreign key. And the relationship, we call them inner link, the links between the tables. We write all these in what is called data dictionary. Okay, that was one question. Let us go to other questions. Please give yourself some time and draw on my screen. Answer this. We did that before in the notes. It is already copied in the notes. So let us do it again. A field in one table that links to a primary key in another table, this is the foreign key. A unique identifier for each tuple is a record. This is the primary key. A data item represented as a field within a table, this is the attribute. The concept of object in a system we want to model and store data about, this is an entity. Identify 3 tasks she can perform using the database development DBMS developer interface. Let me show you this practical. Let me show you this. This is Access. And this is a blank database. This is a blank database. And this is the developer interface, create. This is the developer interface. You can create a table. You can create a query. So this is database management system developer interface. You can create a table. You can create a query. You can create a form. You can create a report. So you can create everything you need to create with buttons without writing code. We write code using data definition language, data manipulation language, structured query language. We will study this. But these are the things that can be created using database developer interface. Create table, set up relationship, create form, create report, design a query, not run a query. Okay? Okay. Please give yourself some time to answer this. Please give yourself some time. This is talking about entity relationship diagram. So find here an entity. Put here the name of entity. Put here the name of another entity. Put here the name of a third entity. And see how and draw links to show how entities are linked using one-to-many relationships or so. Please give yourself time to try this yourself. This is exactly the example that was in my lecture. So draw entity relationship ER diagram for the normalized database. Next lecture, inshallah, I will tell you about normalization. I cannot complete that chapter in one lecture. Okay, so you have to draw something like this. You have an entity called customer. You have an entity called holiday. And if you attempt to link customer to holiday, it's gonna be many-to-many relationship. You cannot do this because the database is normalized. So we have what is said to be link table. This is the link table, okay, where customers link to booking, and this is one-to-many. You have to draw this. You have to draw this. Customer link to booking, and this is one-to-many relationship because the customer is welcome to make as many bookings as possible. And holidays link to booking because every holiday, for example, a trip with 50 seats will have 50 bookings. So this is another symbol that shows one-to-many relationships. If you draw this here, you earn 3 marks. And then you mention the primary keys and foreign keys. And they ask you why the holiday database is in the third normal form. We haven't studied that yet. I will stop here, but you have to go through other examples. Okay? I will stop here, and next lecture we finish all about database. Thank you very much for your attention.